Good morning, everyone. This is Amit Kumar Singh, and welcome to yet another session on transportation problem. So, probably today will be last class on transportation problem, and in this class we'll discuss the problem which came in previous year of your values university exam. So, we'll do that problem. So, you can see this problem. I can show you the problem. This is the problem which came. I believe this problem has came. So you can see this problem. So this is the problem 2018. So this is a 2018 question paper. And in this question paper, if you see the 15 marks problem, this is the problem. You can, I believe everyone can see this problem. So we'll discuss this problem today in this class. So every year you can expect around 15 marks or 10 marks problem on transportation problem. With this you can understand how important is this chapter called transportation problem. So when we talk about transportation problem and while solving the problem in transportation, if we see a kind of problem which is more or less is very common for your value city exam, is the unbalanced transportation problem with the objective called maximization. So if you read this problem, case study 12, a company has 3 factories and 4 customers. The company furnishes the following schedule of profit per unit on transportation of its goods to the customers in rupees, and there it gave the 4 customers A, B, C, D, and it is given the 3 factories for that PQR and the supply and demand that is given to you. Now the problem is that you are required to solve the transportation problem to maximize the profit and determine the resultant optimal profit. So this is the problem which we want to solve in this class. So if you see in this problem, while reading this problem, you would have easily realized that the data what is given inside the matrix, that data is the data of profit. So if the data is of profit, then you know that the objective function for you will be the maximization of the profit. And if the objective function of you maximization of profit, if data is talking about profit and the objective function for you is to work on the maximization of profit, then what you will do, then if you solve writing the objective function for this, you will write maximization of profit and maximization of Z is equal to the maximizing the profit. And then if you write your constraints and other things, and then if you try to solve this problem by transportation problem, you know that the first step to solve the transportation problem is to find the initial basic feasible solution. And whenever you are trying to find the initial basic feasible solution, I told you that the initial basic feasible solution can be only found for those data which are given in minimization. So if your objective is minimization, then only you can find the initial basic feasible solution. Why, sir? Because that is the constraint. Like, in order to find the initial basic feasible solution, the data what should be given, it should be in minimization. But here if you see, the data is of profit, and so because the data is of profit, so the objective function what you need to work on is maximization. So the first thing what you need to do, you need to convert the maximization objective into minimization objective. So that is the first thing what you will do. Then the next thing what we can observe here, that the total sum of supply for this problem is 200 and the total sum of demand for this problem is 150. So if you realize the second thing, that the total sum of demand here is 150 and the total sum of supply here is 200. Again, now we can realize that this is unbalanced problem. Now whenever we get the transportation problem, we have two concerns. One concern is that it should be a balanced transportation problem. The first thing. Next thing is that it should be based on minimization. Now both things are violating here. So if we see, because this question comes in exam, so if you see this problem here, both things are violating. This is neither a balanced transportation problem, neither in this problem the objective function is minimization. So both the thing will do. So if you see in this problem, in this problem, neither the objective function is minimization, neither the objective function is minimization, and neither this is balanced transportation problem. Now we have both the problem. Now what problem will solve first? First we'll make this as a minimization objective function. So once you see both the constraints are violating, now what constraint should you work on first? First thing what you need to do whenever you get the problem, imagine both the conditions are violating. So first preference what you will do, you will give to minimize the objective function. So here if you observe, now it's because now if you see this problem, so because in this, because it is unbalanced, is because this is unbalanced transportation problem, because it is unbalanced transportation problem, because it is unbalanced, because this is unbalanced transportation problem, because this is unbalanced transportation problem, but this is unbalanced transportation problem, where where the objective function, where the objective function, where your objective function is maximization, here your objective function is maximization. So what we'll do, so we have to correct both the thing. We have to make this unbalanced transportation problem into a balanced transportation, and also we have to change the objective of this function from maximization to minimization. So both the things we need to correct. Out of both the things, we'll give preference to maximization to minimization. So because this is unbalanced transportation problem where the objective is maximization, so what we will do, so the first we will convert the maximum matrix into minimum matrix. The first thing what we'll do, will convert the maximum matrix into minimum matrix. That is the first thing what we'll do. So that is the first thing what we'll do. So if you notice in this problem, you have maximum matrix, and how to convert the maximum matrix into minimum matrix. How will you do that? So for doing that, what you have to do, already we have done in the previous class, but again kind of revision for you. Out of all the element, you see the element which is the greatest. Out of all the element, you see the element which is the greatest. So all the data is of profit matrix. So out of all these elements, see the data which is the maximum. So the data which is maximum is 44. Now in order to convert the maximum matrix into minimum matrix, subtract all the elements from 44. So 44 minus 40, 44 minus 25, 44 minus 22, then 44 minus 33, 44 minus 44, 44 minus 35, 44 minus 30, 44 minus 30, like this you will do. So you have to convert the maximum matrix into minimum matrix. Please everyone do fast. I believe everyone sitting with notebook and pen. So I'm expecting everyone to convert this maximum matrix into minimum matrix by subtracting all the element of this matrix by 44. Everyone do fast, subtract all the element of this matrix by 44. So subtract all the element of this matrix by 44, everyone. So convert the maximum matrix into minimum matrix. Subtract all the element of this matrix by 44. Convert this matrix, maximum matrix, into minimum matrix. Everyone fast. So you have to convert this maximum matrix into minimum matrix. So here in this problem, both the constraint we have, that in this problem, this is neither a balanced transportation problem, neither the objective function is minimization. Out of both the constraint, first we'll give preference to converting the maximum matrix into minimum matrix. First thing we'll do, once we're done with this work, then we'll convert the unbalanced into balanced. So I believe everyone have done by this time. So let me go, let me write down. So we'll convert the maximum matrix into minimum matrix. Now, if you noticed, so 44 minus 40 is 4. Then this is 19. 44 minus 25 is 19. 44 minus 22 is 22. 44 minus 33 is 11. 44 minus 44 is 0. 44 minus 35 is 9. 44 minus 30 is 14. 44 minus 30 is 14. 44 minus 38 is 6. 44 minus 38 is 6. 44 minus 28 is 16. 44 minus 30 is 14. Okay, and your supply value, if you notice your supply is 100, 30, then 70. You see your demand is 40, 20, 60, 30. So if you do now what you have done, if you see this matrix, now if you see this matrix, this is minimization matrix. So I have converted the maximum matrix into minimum matrix. Now this is minimization matrix. Now in this matrix, the total sum of demand is 150, and the total sum of supply, if you see, that is 200. Now we have converted the maximum matrix into minimum matrix. Once we have converted the maximum matrix into minimum matrix, that was the first condition, that whenever you are solving a transportation problem, the objective function should always be minimization. Okay, that part is done. Now the next thing is that you have to make this problem as a balanced transportation problem. Now you have to make this problem as a balanced transportation problem. Now if you want to make this problem as the balanced transportation problem, now how will you do that to make this problem as a balanced transportation problem? For that you will add dummy row or dummy column. So previous class, we have discussed the unbalanced transportation problem. So whenever you have unbalanced transportation problem, you'll make the unbalanced transportation problem into balanced transportation problem by adding dummy row or dummy column. Now if you understand here, what is less here? Here demand is less than supply. So how will you make the demand equal to the supply? If you add a additional demand of 50. So if you add an additional demand of 50, if you add one more column, called column 5, where all the elements are 0, and the total demand is 50, then the total demand will be equal to total supply. That is the work what we need to do, guys. I hope you are understanding. So that once you made this, once you made the objective function from maximization to minimization, the next thing what you need to do, you have to make this problem as a balanced transportation problem. So for making that balanced transportation problem, what you'll do, you'll add a dummy row or dummy column. So for this, if I add dummy row or dummy column to this problem, if I'm adding a dummy row or dummy column, if I'm adding a dummy row, now I'm just, because I want to make the total demand equal to total supply. So for that I added a dummy column. So here I added a column called 5, and which should have value called 50. So if I add a column called 5 and which should have a value called 50, now the total supply, no change in total supply. Total supply was 100. Total supply was 100, 30, 70, that is 200. And this dummy column what I added, it have value called 0. The purpose of adding this dummy column just to make this problem as a balanced transportation problem. Now we have removed both the error. It had the objective function called maximization. So we converted that maximization issue by converting that maxima matrix into a minima matrix. Next thing what we have done, we have converted the unbalanced transportation problem into a balanced transportation problem. Now we are free from both the error. Now we can solve this problem, and we know how to solve the problem. That the same steps what we have to follow. First thing, we'll find the initial basic feasible solution. In order to find the initial basic feasible solution, we'll follow either of the method. Either we follow in least cost method, or matrix minima method, or Vogel approximation method. After we found the initial basic feasible solution, we'll do the test of degeneracy. Once we do the test of degeneracy, then we'll do the optimality test by UV method. The same thing what we'll do, but the final answer what we get, no, the final answer what we'll get once we check that for all the unoccupied cells, if everything turned to positive, if we realize that that is the final solution, now the allocation whatever we get, that allocation whatever we'll get, we'll put that allocation on the given problem. So we put that allocation on this data. So because this is the original data, if you remember for this problem, your objective function is to if you remember that for this problem, your objective function is to maximize the total profit. What is your objective function? If you remember, your objective function for this problem, if you remember, your objective function for this problem is to maximize the profit, to find the maximal optimal profit. So you have to find the, if you remember the problem, if you see this problem, what you have to find, you are required to solve the transportation problem to maximize the total profit and determine the resultant optimal profit. So you have to find the, if for this problem, what you have to find the optimal profit. So the final answer whatever you get, you will put that allocation on this data, and then you will get the optimal profit. I hope you'll remember, already we have done like this in previous class. The previous class only thing was that the problem was balanced transportation problem. Today what we are doing is unbalanced transportation problem with the objective function called maximization. Okay, so this kind of question only which come for your exam. Now what you do, now will determine the initial basic feasible solution. Now, in order to determine the initial basic feasible solution, we can use any method. We can use least cost method, or matrix minima method, or Vogel approximation method. Any method you can use. Then you have to use looping and all. You have to work on optimality. So out of all the three methods, I always prefer the Vogel approximation method. Although that method is complicated, but by that the answer what you get is very close to optimality. So what I'll do now, I'll find the initial basic feasible solution by Vogel approximation. So let's start solving this. Let's start using the Vogel approximation method. Now if I use the Vogel approximation method, now do that. Now use the Vogel approximation method. So if I use the Vogel approximation method, I'll find the penalty. I'll find the penalty one by one. So same thing, what you will do, the lowest element in first column is 0. So 4 minus 0, you will get 4. Then next one is 9 minus 6, you will get 3. Then next one is 16 minus 14, you'll. Then the next one is 14 minus 11, you'll get 3. Then next one is 0. You know this, every time I'm doing the same thing, you'll find the lowest element in every row or every column. You subtract that element from the next highest element. So that I have done for column wise. Now let's do. Now already we have done for column wise. Now let's. Already we have done for column wise. Now let's do for row wise. Now, so if you see row wise, now the lowest element here is 0. So 4 minus 0, 4. Then here 9 minus 0 is 9. Then here 3 rows are only there. 6 minus 0, this is 0. So you will do this work row wise and column wise. Now see out of 3 rows, you have the 3 values called 490. And if you see the column wise, the values are 43230, which is the highest value. So the highest value is 9. So now you will enter in the second row. Now the highest value is 9. That means I'll give preference to the second row. In that second row, in this second row, if you notice what is the lowest element in the second row, the lowest element, if you notice in the second row, now in the second row, the lowest element in the second row, now in the second row, the lowest element is 0. So 2 zeros are there. So out of the zeros, you can give preference to any 0. Now suppose if I work on this 0, suppose if I work on this 0, then the demand for that is 40 and the supply is 30. So I'll put 30 here. If I put 30 here, now no allocation can be done. This is done, and this left is 10. Now this part is done. Now again, the difference, if you see, the difference of this would be 4 only. This would be dash and this would be, okay, here the third row, the difference should be 6 now. 6 minus 0, this should be 6 before. Now again this would be 6. So now if you see column wise, now the difference, this would be 2. Now this would be 19 minus 6, that would be 13, and this would be 6, this would be 3, this would be 0. So out of all the differences, you can see which is the highest difference. The highest difference you can easily understand. The highest difference is 13. So the 13 it will enter. In that the lowest element is 6. In that the lowest element is 6. In that the lowest element is 6. So I'll give preference to 6. So the demand for that 6 is 20, and the supply, the demand for that is 20 and the supply is 70. So what is the maximum you can do? So that would be 20. This is 20, this part is done. So this is 20, this left is 50. This part is done. If this is 20, so if this is 20, now nothing can be allocated to anything to the to the second column. So that part is done. Now you can put that is 20. Now I can go ahead. Now if I go ahead, now find the value. So now this, the difference is 2. This part is done. Now the difference is 6. Now here the difference is 3. Here the difference is 0. So out of all, in column wise, the greatest value I can see is 6. Now do row wise. Now do row wise. Now do row wise. I believe everyone is doing in the notebook. Now if you see row wise, the difference of that is this is 4 minus 0, that is 4. This is done. Now this is 6 minus 0, 6. Okay, so 3 rows are there, 4 columns is there. So if you see row wise and column wise, the greatest value what I can is 6 only. So the greatest value I can see is 6. So out of 6, I can choose any 6, either row wise or column wise. Normally we give preference to the column wise. So if you see the third column also, you are getting value called 6, and in the third row also you're getting greatest value is 6. So you can give preference to anything. So suppose I'm giving preference to the column. So if I give preference to the column, the third column, there are two values. In third column, there are two values are there, 22 and 16. Out of that, the lowest one is 16. But you can see the demand for that is 60, supply is 50. So what you can do, you can put 50. So if you put 50, now this is done. This is done. So you put 50 here. So you put 50 here. Now this is done. So still 10 is there. Still 10 is there. Still 10 is there for this. So no more allocation for third row. So you put 70. The third row you can see the maximum is 70. That is done. For second row you can see maximum is 30. That is done. For the first row you can see the total is 100 and nothing is done for the first row till now. If you see the first column, the total is 40 till now, you have done 30, 10 is left. Second column done, third column 10 is pending, the fourth column nothing is done, fifth column nothing is been done. Okay, now going further, we'll do the same work again. Now again if you see the first row, the difference is 4. Again if you see the first row, the difference is 4. 4 minus 0. Then second row, it is nothing can be done. Third row, nothing can be done. 3 rows are there. So only the first row, its value is 4 that we can see. Now okay, now I don't have space for me. Now first column it is 4. First column it is 4. Second column you can see I don't have space to write it down. If I go down, then I can't see. So the first column you can see the value is 4. The first column you can see the value is 4. Then second column, if you see done, everything is done. Second column, everything is done. Second column, everything is done. Second column, everything is done. For the second column, everything is done. Now the third column, if you see the only one value is left, called 22. For third column, only one value is left, called 22. The fourth column, only one value is left, called 11. For the fourth column, only one value is left, by 11. And the fifth column, it is 0. So out of all differences, the greatest one is 22. Now it will enter now. It will enter now for the solution. Now if 22 will enter, then if you noticed only the value left in the column 3 is 10 and the supply is 100. So what you will do, you will put 10 here. You will put 10 here so that this is done. we'll put 10 here so that this is done, and the left one of supply is 90. So you do allocation for that. So no more column 4, no more column 4. If you notice, now if you notice the row 1, if you notice the row 1, now the difference of row 1, if you notice the row 1, now the difference of row 1, that is again 4 only, again the 4 only, second row done, third row done. So the first row 4 is there, first row 4 is there. Now if you see the column wise, 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 now if you see the column wise, if you see the first column, the value is 4, second column done, third column done, fourth column it is 11. So 4 dash dash 11, 4 dash dash 11 0. So it is 4 dash dash 11 0. Now out of all, the greatest value is 11. So that will enter, the greatest value is 11. So it will enter. Now you can see the demand for that fourth column is 30 and the supply is 90. So how much you can sustain? You can sustain, that is 30. So if you put 30, now this is done. Now the value left, it was 90. 90 minus 30, the supply left is 60. Now the supply left is 60. Okay, so you are done with that work. Now if you notice, what you can do, 60 is left. Now everything is done. Now if you notice, everything is done. Okay, if you see second row is done. Okay, third row is done. Okay, now first column, the value is, now first row only 4 is left. First row, if you notice, 4 is left, 4 minus 0. Because if you see second row and third row, everything is done. First column 4 is left, and second column everything done, third column everything done, fourth column everything done, and then fifth column only 0 is left. So you will give preference to 10. So you will put 10 here. If you put 10 here, then this is done. So if you put 10 here, now it is left is 50, and then you put 50. So this is the way. So now to confirm that you have done correct or not, just do the sum of row and column. So first column, the sum should be 40. Okay, it is correct. Second column, the sum should be 20. Yeah, it is 20. Third column, it should be 60. Yes, it is 60. Fourth column, it should be 30. Yes, it is 30. Fifth column, it should be 50. Yes, this is 50. The first row, it should be 100. So 10 plus 10, 20, 20 plus 30, 50, 50 plus 50, 100, correct. The second row should be 30, correct. The third row should be 70. So 50 plus 20, 70, correct. So once you're done with this, so this is the final data what you'll get after your allocation. So do this work. So 4, 10, then 22, 10, 11, 30, then 0, 50, then 0, 30, then 6, 20, 16, 50. So this is the what you will do. Now this is what you got. So this is the final allocation value what you can get. Everyone, please write it down. If you have not written down, please write it down so that we'll continue after that. Everyone, I'm giving you 2 minutes time. I believe you're done with this. So let's go ahead. So you can do that the test of optimality. So test of optimality should be 5 plus 3 minus 1 means 7 allocation. So you can count 1, 2, 3, 4, 5, 6, 7. Okay, 7 allocation there. So you can do the test of degeneracy, not the test of optimality. Everyone in exam, you write the test of degeneracy, that the total number of allocation should be m plus n minus 1. So I can do 5, 1, 2, 3. Let me write down the values. It was 4, 10 allocation, then 19, then it is 22, 10 allocation, then 11, 30 allocation, then 0, 50 allocation. Total sum should be 100. Then it is 0, 30. So I started with this only. Then 9, 14, then 14, then 0. Then it was 6, 6, 20. Then it was 16, 50, then it was 14, then 0. So just reconfirm. Anyone have any doubt, please ask me. This is the allocation what we got on this data. This is the allocation what we got. You can just confirm these values. Okay. Now once you've seen this value, now let's do the test of optimality. So let's do the test of optimality. When we do the test of optimality, we use UV method. So U1, 2, 3, then V1, V2, V3, V4, V5. So you got U1, U2, U3, V1, V2, V3, V4, V5. Out of that, put one variable equal to 0 because the maximum allocation is done on row 1. So I put U1 equal to 0. So this become 4. This become 22. This become 4. This become 22. This become 11. This become 0. Now once this is done, I can find the other values. So you know the formula. For the occupied cell, we follow the formula called Cij equal to Ui plus Vj. So this would be minus 4. So this would be minus 4. Then this would be minus 6. So you got U1, U2, U3, V1, V2 is left. So 6 plus 6, you will get 12. So you got V1, V2, V3, V4, V5. Okay. Now you remember the formula, right, guys? I believe everyone remember the formula. I think so many classes we are doing same kind of problem. The optimality. By this time, I believe everyone should be very confident. Now, so directly I'm doing everything. So for unoccupied cell, I will see the values. So if you see, if I go to this value called 19, so the total U plus V is 12. So 19 minus 12, you get positive value. So you are getting positive value. Now, if I come to this cell, so that is A22. So you can see 12 minus 4 is 8, 9 minus 8, you will get positive value. Now you can come to this cell. Now if I come to this cell, then 22 minus 4 is 18, 14 minus 4 is 14 minus Okay, so you're getting negative value here. So 22 minus 4 is 18. 14 minus 18 is minus 4. So you got negative value here. Okay. Now the next thing, if I come to this cell, this is 11 minus 4 is 7. 14 minus 7 is positive. Now if I come to this cell, this is 0 minus 4. If I come to this cell, 0 minus 4 is minus 4, and then 0 minus of minus 4 is plus. So again this is plus. Now if I come to this cell, then 4 minus 6 is minus 2. Then 6 minus of minus 2, you'll get positive value. Okay. Now if I come to this cell, then 11 minus 6 is 5. 14 minus 5 is positive. Then if I come to this cell, this is also positive. So now the only one value which is negative, you can see. So there is only one value you're getting. Otherwise, this would have been an optimal solution. So there is only one value, you're getting negative value. So what I will do, I have to make this as optimal. So in order to make this as optimal, what I have to do, I have to follow the game of looping. So I have to start looping here. I have to start the looping from here, and where I can only go on occupied cell. So I can do this. So you can do the looping here like this. This is plus 1, this is minus 1, this is plus 1, this is minus 1. I can, so you looping, whenever you work on looping you only go on occupied cells. You cannot move on unoccupied cells. This is A, this is B, this is C, this is D. Okay. So A, B, C, D. So you can see A I'm writing as theta. Okay, so A is theta, that value is negative, you have to make it positive. So the B will be, it's a negative sign, that would be 10 minus theta, and C will be 10 plus theta, C will be 10 plus theta plus sign, and D is 30 negative, so D would be 30 minus theta. So you got A equal to theta, and because when you follow the formula, that for unoccupied cell, so when you follow the formula for unoccupied cell, then for the unoccupied cells, so we use the formula called Cij minus Ui plus Vj. So when we apply this formula of that Cij minus Ui plus Vj, then one of the cell you got negative value. So that negative value, what you got, so one of the cell you got negative value. So in order to make the negative into positive, so we need to reshuffle the allocated value what we got within the cells. For reshuffling the allocated value what we got, so for that we make a loop, and when we make the loop, so we play this game by making a closed geometrical representation where the loop only travels on the occupied cells, and then whatever value you want to change, we put that value as theta, and then we see the allocation of other cells, and simultaneously with respect to the theta we give them value depending upon what is the value allocated to them and what is the sign they have. Then out of all negative theta, you can see all the negative theta value. So there are two negative theta you can see. So there are two negative theta value of B and C, B and D. Those are 10 minus theta and 30 minus theta. Uh, out of that, find the value which is the lowest. So the lowest value is 10. So it means theta is equal to 10. So if theta is equal to 10, then the B would be 0. C would be 10 plus 10 means 20, and D would be 30 minus 10 means 20. So that values we got for A, B, C, D. So why we are doing, we are reshuffling the allocated values what we before, by when we are using the initial basic feasible solution. The time when we are using the initial basic feasible solution, that time we allocated some value to each cell. So the time when we allocated that values to the each cell, so maybe that value is not optimal. Otherwise, if that value would have been optimal, then for all the unoccupied cell, we would have got the positive answer. Because we did not get the positive answer, so we need to make them optimal. So because we did not get the positive answer, so we have to make it optimal. So in order to make that optimal, So we follow this game. So we'll follow this game till the time for all the unoccupied cells we don't get positive answer. So I already have made a lot of videos on working on looping and all. So anyone have doubt, they can watch the previous videos on transportation problem. This is a little bit advanced session. Here we are doing the one of the difficult problems. So if anyone starting from this video, then probably they will have a doubt. Otherwise, those who are referring from day one, the video one, then I don't think anyone have doubt. So you just need to do this work. So you just need to do this work of allocation to them. So you need to substitute these values to them. So now you can see this value. Now I'll do allocation based on the theta, do allocation for these cells. Everyone do fast. So do the allocation based on this. Everyone do fast. So once you're done with this, so now I can do 420, then 19, then 22, then 11, 30, 11, 30, then 0, 50, then 0, 20, then 9, 14, 10, then 14, 0, then 6, 620, then 16, 50, then 14, then 0. This is V1, V2, V3, V4, V5, U1, U2, U3. This is 0, this becomes 4, this is 11, this is 0, this is minus 4, then this is 18, this is minus 2. So you know the formula that Cij equal to Ui plus Vj. With that, I found the value of U1, U2, U3, V1, V2, V3, V4. So this would be 8. So 6 minus of 2. So you get 8. So you can quickly find the value of V1, V2, V3, V4, V5, U1, U2, U3. So you just need to follow the formula for the occupied cell. So for the occupied cell, so for the occupied cells, we follow the formula called Cij is equal to Ui plus Vj. So with this formula, we'll put the value of U and V. Once that part is done, then we'll check for unoccupied cell. So for the unoccupied cell, so we follow the formula called Cij minus Ui plus Vj. Now we can do for unoccupied cell. If we get all positive, means we got the optimal solution. Otherwise, we have to keep doing this work till that time we don't get optimal. So in exam, when you get this problem, so try to do this problem in beginning only. So don't wait for the end. So at the end time, if you do this problem, then there's a very high chance that you'll make silly mistake and you lose your, because ultimately you have to make everything positive. You could not able to make positive, means unnecessary you lose your 15 marks. So my suggestion for you, always do with Vogel approximation method. Now if you see this cell, so this is 8, you get positive. So 19 minus 8, this is 18, again this is positive. 22 minus 18. So now if you come to this cell, so this is 8 minus 4, that is 4. So 9 minus 4 is positive. Now, if you see this, 11 minus 4 is 7. So 14 minus 7 is positive. Now, this is positive. Now, 4 minus 2 is 2. So 6 minus 2 is positive. Then 11 minus 2 is 9. 14 minus 9 is positive. Now, 0 minus 2, everything you got positive. So you have to do this work till the time you don't get everything positive. So you got positive, everything positive, means 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 now you got the optimal solution. Now when we have to find the cost, so we used to multiply. Then the optimal cost is 4 into 20 plus 11 into 30 plus 0 into 50. So plus 0 into 20 plus 9 into, then that we are used to do. But if you have to understand that this allocation what you got, so you have to find the total profit. You have to find a maximum total profit. That is the optimal profit. Once you get everything positive for the unoccupied cell, so you have to understand this is the ideal allocation. So you have 3 rows and you have 5 columns. Now, based on this, what you will do, you'll put the original values. So we'll do that work. So you have 5 rows, and let's do go down, go down, go down. So now the allocation are, you see the allocation. What are your allocation? Your allocation are, you see your allocation are, this allocation is 20. Then fourth column, 1 2 3 4. The fourth column is 30. The fifth column is 50. These are your allocation. This is 20. Then this is 10. Okay. Then this is, if you see, this is 20. Then this is 50. These are your allocation. So you can see this allocation. These are your allocation. This allocation, that is optimal allocation that you got from this data. So from this, because you got everything positive, so means this allocation is optimal. Your allocation, these are your allocation. Simply wrote down these allocation. So these are your allocation. So simply I wrote down this allocation. This is A11, this is A12, this is A13, this is A14, this is A15, this is A21, A22, A23, A24, A25, this is A3, this is A32, this is A33, this is A34, this is A35. So this is the allocation where what is A1? A11 means first row, first column. A11 means first row, first column. A12 means first row, second column. A13 means first row, third column. Where, so I hope you are understanding. So you got this allocation. Now this allocation will put on the original data. So what is the original data? That was the original data of profit. So why we converted that original data into cost metrics? Because that way only we can solve the problem. Now write down the original data. So what was your original data? Write down your original data, what is given in the problem. So write down your original data, what is given in the problem. So this was your original data. If you remember your original data, what is given in the problem. So write down your original data. Come back to this. So this is the original data. You have to solve the problem on this data only. So this is your original data. You have to solve the problem on this data only. But because we cannot solve the problem on this data, that's why we converted this into minima matrix. Then we make it balance all x y z we had done. I hope you remember. But the ultimately, because ultimately you have to find the total profit, total optimal profit that you can do only on this data. So what I'll do now, let's write down the original data. Everyone, please write down these values. So if you see, so the values, so you can see you can substitute these values. Whatever values answer whatever you got. So you can substitute that answer on these values. So the answers, whatever you got. So this answer, this was 20. So this is the allocation what you get. This is 20. This is 30. This is 20. This is 30. Then this was 20. Then this is 10. Then this is 20. Then this is 50. So this is the allocation what you got. With this you can find the total profit. You can do this work, or I can write it down. I can bring it down. So I can bring it down. So this is the final allocation that I put it there. Let's go down. Now the final data, what you see. Now your original data. So the original data if you want. So the original data if you want. Original data if you want. This was the original data. This was A, B, C. This is your demand. So this was 40. This was 44. This was 38. Then this was 25. Then 22. Then 33. Then you can put 0, 0, 0. This was your original data. This was 35, 30, 30. Then this was 38, 20, 30. 1 minute. So this was your original data. Now on this data, you can, on this data, you can see your allocation. What are your allocation? You can see these are your, on this original data, you can see your allocation. So these are your allocation. So if you substitute your allocation on the original data, if you substitute your allocation, whatever allocation you got, if you substitute your allocation on the original data, so if you substitute your allocation on the original data, so let's substitute your allocation on the original data. So this is 20, this is 30, now this is 50, then this is 20, then this is 20, then this is 50, what I can do, I can find my optimal profit. So my total optimal profit will be 40 into 20 plus 33 into 30 plus 0 into 50, no need to do. Then 44 into 20, then plus 30 into 10 plus 38 into 20 plus 28 into 50. I can do this. So with this, if I solve, I'll get 800 plus 990 plus 880 plus 300 plus 760 plus 140. You can do the sum of this. The sum of this. If you do the sum of this, if you do the sum, so 990 plus 800 plus 880 plus 300 plus 760 plus 140 is 900. 760 plus 140 is 900. So this is 0. This is 9, 8, 17, 1 carry. So 9 plus 8 is 17. 9 plus 8, 17 plus 1. That is 18. 18 plus 8, 26. 26 plus 3, 29. 29 plus 9, 38. 29 plus, so 38. So your optimal total profit would be 3870. So that is your final answer. So this is your final answer. This came for your exam also for 15 marks. So you have to do like this. So I hope you understood how to do this. So anyone have any doubt, please ask me. Before I wind up the class, anyone have any doubt, please ask me. So this comes every year for your exam. 15 marks question, it used to come. So in exam, when you see this problem, you start from the end. When you see this problem, do neat work. Before you do this work, before every step, do rough work. Make sure in the rough work you do properly. Once you're satisfied with your performance in the rough work, then only make it fair. Because if you do silly mistake while writing that final data, then if you cross it, then again write it and all, so examiner will not like it. So you do rough work in the behind, solve the question in rough work completely, and then tally the same thing what you have done in the rough work on the main sheet. So that in main sheet it should be neat work and easily you get 15 marks in exam. So although this looks lengthy, but it is easy. Only thing it requires concentration. Silly mistake you do anywhere, although you are very intelligent, but you end up in losing your marks because you just made some silly mistake here and there. You just need to avoid that, making that silly mistake. If you're clear with your thought process on how to solve the problem, you will get the answer very easily. And out of all the three methods, if no method is given, I always prefer the Vogel approximation method. The same problem, if I try by northwest corner method, maybe I'll take another 15-20 minutes more. So the problem with this method is that we have to do this method till the time we don't get positive value. So there's no shortcut for working on these kind of problems. Imagine if you make somewhere mistake also, you'll never get to know because you keep developing loop and you keep working on that way. Okay. Yeah. So that should be 1400. Okay. So if this is last one, no, 1400. Okay. So let's correct that part. Okay. Very good. So the last part is this is 760. This is correct. Huh? So this should be 1400. Okay. So guys, then your answer won't be this. So 900 if I subtract 900 from this, so if you subtract 900 from, you got 3870, no? So from 3870 subtract 900 from 3870, 2970, subtract 900. So if you subtract 900, you will get 2970. On 2970, what you do, add 760, add 1400 plus 760. So 1400 plus 760, that works. So this is 13, 1 carry, so 21, 2 carry, 5130. You get the total cost as 5130. Hmm. Hmm. Clear? Thank you, Sneha. So anyone have any doubt? So this is your optimal total optimal profit. So this would be your total optimal profit. So this like this every year. If you see your question paper, every year this question comes. You see this is 2018. So if I go ahead, this is 2018. Then if this, which year is it? This is 2017. This is 2017. So if you see 2017, now you can see again the same problem. Same problem, Kimor. Same data. Oh my god. 2017 and 18, same question came. No change. Oh my god. This first time I saw. How come they can repeat the same question? 17, 18, the same problem. The problem what we did just now, it came in 17 also, it came in 18 also. Okay. Now you can go ahead. Now you can see 17, 18, the same problem came. Now this problem I told you to do 10 marks question. So this was the transportation problem only, 10 marks thing. So here they gave you the cost also, they've given the cost. Only thing, this was not balanced. I told you to do this problem. I don't know how many you did or not. Total sum of capacity, if you see, the total sum of capacity if you see is 1900. Total sum of requirement if you see is 2000. So it was not a balanced. So it is actually unbalanced transportation problem where the data is given in cost. So you will make it balanced, then you will solve it. So this came for 10 marks. This came for 10 marks. So now here this year LPP came for 15 marks. Already I have done this problem for you in past only in LPP chapter when we are solving by simplex method. We have done that problem. Now, so you can see this every year. This question comes, transportation problem. Every year it is coming. So there's no doubt on that part. So by this you can understand how important is this chapter. Okay, so guys, so let's say goodbye to all of you. I believe everyone's clear. From tomorrow we'll start assignment problem. You can see assignment problem also. Every year it comes for the exam. So when you see the question paper, you can see this question number 4. So I think 10 marks question. Assignment problem is not difficult. It's 5 marks, but it comes every year in exam. So from tomorrow we'll start assignment problem, which is the another sub part of transportation problem. So with that intention, I'll wind up the class. Anyone have any doubt? Anyone want to ask anything? Okay, so I believe everyone's clear with this. No one have any doubt. So thank you everyone. Take care. Bye. See you tomorrow.